Today, the problem that we're going to be covering is called branch sums. And the problem says write a function that takes in a binary tree and returns a list of its branch sums ordered from leftmost branch sum to rightmost branch sum. And the problem defines that a branch sum is the sum of all values in a binary tree branch, and that a binary tree branch is the path of nodes in a tree that starts at the root node and ends at any leaf node, right? They also give us that each binary tree node has an integer value, a left child node, a right child node, and that children nodes can either be another binary tree or a subtree, or they can be null or empty, right? So I think it's important to really understand what a branch sum is. So what a branch sum is saying is that, so starting at the root node, right? Let's say, for example, we go left and we keep going left until we cannot go any further, right? The first branch sum that I would see is 1, 2, 4, and 8, right? And this would be considered a branch sum because we're going from the root node of 1 all the way down to a leaf node. And a leaf node has no children, which would be 8, right? So from 1 all the way down to 8, that would be one branch sum. Another branch sum would be 1, 2, 4, and then 9, because 9 is also a leaf node, right? Another one would be 1, 2, 5, and 10, right? And then on the right subtree, it'd be 1, 3, and 6, and 1, 3, and 7, right? And again, the reason these are branch sums, or this is a summed branch, is because we're starting at the root node and traveling as far as we can until we reach a leaf node, right? And in this tree, there are 1, 2, 3, 4, 5 leaf nodes, so that means we should have 5 outputs in our answer, right? And essentially, the branch sum is just adding the values of this tree up together and then inserting it into a list, right? So let's start, like, sort of specking this thing out. So let's first thing we're gonna do is we're gonna initialize an array list for our answer, right? And I think we should also make use of helper method. One thing that I'm seeing here is that this looks more or less like a tree traversal problem, where at each recursive step we're going to be somehow adding the value of the node that we're currently looking at, right? So let's see what we got. So okay, make use of helper method for recursive step. Okay. And let's start specking out that helper method, because that's going to sort of be the meat and bones of this question. So we can do this. Create a list, integer, list, sum. Okay. And then let's call our helper method branch sum helper. We can assume that it's going to take in a binary tree, so it's going to take in root, and let's think of what else we should use for this. So let's say public static void. Well, we know another thing that it's going to take in is the current sum. So initially, when we call our helper method, the current sum is going to be 0. And then we also know it has to take in our list of integers, so it can be populated while it's doing the recursion to traverse the tree, right? So branch sum helper, it's going to take in a binary tree and call it node. It's going to take in an integer, call it current sum. It's also going to take in a list, and just call this result. right? And it's not going to return anything just because, we already initialized an array list up here, and we're just going to populate it, and then so nothing needs to be returned here. Okay, so when we're doing our recursive step, I think the first thing that we need to check is if node equals null, then just return, right? And this is basically saying if we've gone past our leaf node in any possible way or any scenario, then we just need to don't do anything, just return from that recursive step. So now for the actual implementation of this helper method, I think the first thing to do that we should do is we should look to recursively sum the node's value at each recursive step, right? So recursively sum the node's value at each recursive step. And we're going to sum the current node's value, right? So what I mean by that, we're going to have our current sum, and then we're going to add the node.value plus current sum, right? So this is it's just gonna append the value of the node that we're currently looking at in this recursive step, right? And then we also need to do a check, right? So one of the things that the question says is it's that the branch sum has to end at a leaf node. And one thing we know about leaf nodes is that they don't have any children. So they can't have a left child and they can't have a right child. So using a simple if check, so we can say, let's write a comment out here for this. So if we see no left child and if we see that the node has no left child and we see no right child, we have reached a leaf node. We can then add current sum to our result list. And what this is saying is it's saying, okay, so once we know that we've reached a leaf node, we know that our current sum should not grow any larger, and it's time to append the current value of current sum to our result list, right? So the way we do this is we say if node dot left equals null and node dot right equals null, right? So basically we're checking that, hey, this node has no children, which gives it the definition of a leaf node. Then we just do result dot add current sum, right? And that's all we really need to do to add a value to our list, right? And then the next part comes the recursive step. And I want you guys to pay attention to the question asked. It wants the branch sums in order from leftmost branch sum to rightmost branch sum. Now, this is an important detail because in your recursive step, it matters whether you traverse the left subtree first or the right subtree first. In this case, you'd want to traverse and do your recursion on the left subtree instead of the right first. So that would give us the order that it would go in is, let's write a little comment. So taking this example over here, the order it would go in is 1, 2, 4, 8, and then it would go 1, 2, 4, 9, and then it would go 1, 2, 5, 10, and then it would go 1, 3, 6, and then it would go, 1, 3, 7. Right? So this is the order that these traversals would happen. Right? So I'm just going to put that all the way down here. So because we want to traverse uh, the leftmost branches first, then the right, here's what we need to do. Recursively, we need to call our helper function, branch sum helper, node.left, because we want to travel left first. We're going to pass in our current sum, and then we're also going to pass in our list of sums, our result list, right? And then on the opposite end, once we finish our left side traversal, we just want to traverse the right side, right? Let's delete this example. And let's look through what we did, right? So, okay, so we initialized the list for our answer. We're going to use a helper method, branch sum helper. It's going to consume a node, the current sum, and our result list. Just one thing in this return statement, we're going to want to return list sum, not a new array list. So return that. First thing we do is we check if the node is null, then we just return. We recursively add the current sum. Then we do this check to see if the node that we're currently looking at is a leaf node, meaning it has no children. And if it is a leaf node, then we add our current sum to the list of our results list. And then we recursively traverse the left subtrees and then recursively traverse the right subtrees. And let's see, let's run this code. Okay, 9 out of 9 test cases passed. Let's submit it. And there we go. Yep, so the key to this problem was just recognizing that it was a traversal. And I think one big, you know, red flag to give that clue away was that it asked for leftmost branch sums to rightmost branch sums. So you knew in some way or capacity you had to go from left to right. So that just sort of screams to me that some type of tree traversal is going to happen here. Um, Thanks for watching. Like, share, and subscribe. Take care.